IDS choices. Is the mic on? I don't know. No, it is not. That would be a good thing.
Thank you. Sorry.
Okay. How about now? Is that better? All right.
All right. We're
Excellent. Now we're in working order. All right. So, now that everybody can actually hear what I'm saying, welcome. As said, my name is Forgotten O'Brien. Talking about some IDS choices and network architecture. So, a little bit of history. Slightly jaded on IDS. Kind of started at Sourcefire, so a little bit of love for snort. Hopefully, most people know what an IDS is. Hopefully, yes, no, maybe. Okay, some of you anyway. All right. So along the way, I ended up taking over a few things. So running a nice little CTF and running another BSides up in Maryland, and a hackerspace and other strange things along the way. Pretty much my entire career has been around the SOC world and defensive architecture. So that's been kind of fun. The last SOC I worked in, we actually combined these two things. Does anyone know roughly what the left is supposed to represent? PLC, Industrial Control Systems. So I actually had the pleasure of building probably one of the first industrial control system security operations centers designed around specifically monitoring a series of power grids, both power distribution, transmission, and getting into some generation. So that was kind of fun. Lots of interesting environments to have snort in. Now I end up teaching folks about snort and SOC work, as well as teaching a lovely class up in Maryland under Point 3. So we end up teaching a lot of classes that are unallocated because hackerspaces and free classes are always good. So, one of the things over the years I kind of put together the phases of SOC monitoring. Kind of the current status quo in a lot of SOCs I've walked into have been somewhere around flailing. Kind of sad, but organizations tend to look at, okay, we have tickets, we need to close tickets, we're getting alerts, we don't know what these mean. We get more alerts than we can deal with, so we're going to rush to close every single ticket we can. And not much thought of actually what can we do to prevent these alerts in the future. A lot of times, a lot of these issues don't get fixed, don't get addressed. No one's looking at how do we deal with this problem. One specific SOC had 1 million events a day on the IDSs for 6 analysts. Clearly, we weren't able to close those tickets. But not an uncommon thing. So, kind of call that flailing, right? If you can't close most of your tickets, you're missing stuff. And you don't know what you're missing. It's kind of scary. Kind of the first step, in my mind, arguably 1 and 2 can be interchanged. I want visibility into my network. What do I have? What's there? What should be there? I know, seems kind of obvious, seems very similar to like SANS Top 20 has things like an asset list. Right along the same lines. So visibility and detection of known threats. So what's out there that everybody knows about, that there's solid rules for, that have been tested all over the place, that we know how to block, we know how to prevent, we know how to deal with these things. When we get an alert for this, it's not going to be a false positive. It's not going to be some random thing. It's going to be an actual issue that we need to deal with. So those two things are kind of the starting point. When I end up walking into most SOC operations, those are the first two things we discuss on this is where to go first. Next is preventing the actual known exploits, right? If you can block ransomware and neutrino and some of the other exploit kits and really basic attacks that we know how to detect cleanly, we're not seeing much in the way of false positives. It's a clear next step, right? Seems reasonable. I've not found many organizations that have gotten to this point where they're effectively blocking all known exploits that are clean, that are you have alerts for, you know these are always going to be true. And then kind of the next phase, as much as the threat folks hate to hear this, to me, once you have those known threats dealt with, then we can start to really look at threats that we may not have such a guarantee on. Things like this bad IP address or this bad user agent string that may or may not be an actual issue. Might be just somebody with a love for Internet Explorer 4.0, for example. Thank you, HP. Or it might, I would rather deal with that after I've dealt with known issues before I deal with the supposed industrial control system malware that was actually HP OpenView thousands of times a day. Actually, about 100,000. So, kind of some story time. So there was a breach recently. Recently is arguable at this point, but one of the most well-known breaches as far as what they've disclosed on how a breach actually happened came through. At least I got as much of the story as I have for any breach I've heard of. So, in this particular retail example, they had a lovely HVAC vendor up in Pennsylvania that got phished. Happens in most organizations at this point. If it's large enough, phishing is a real problem and it's going to happen. Our goal as security professionals is to prevent it from going forward, prevent lateral movement, and from them being able to walk around the network for months or years before we deal with it. Seems like a reasonable possibility. It's good to try to prevent phishing, but trusting the user to do an 100% job of detecting good phishing attempts, probably not. Right? Even IT security professionals get phished. It's hard sometimes. So, kind of that point where, okay, they got phished, fine. They had saved the credentials for our lovely retail target for remote access. Again, the ability to do remote access based on a single credential is probably a bad plan, right? Two-factor authentication's not that expensive anymore. We can reasonably do that. Not too hard. Takes some work. So, they were able to connect. Still, one of the few details that I haven't been able to get was, did they connect through, did they pivot through, or did they actually connect from another site? That would be a fun question for anyone working at the target organization. So, if they were, hopefully they've blocked it so that only valid IP addresses and whatnot could have remote access. That would be another reasonable thing that they probably didn't have set up. So, okay, HVAC vendor, now attacker, gets into the particular store, and they're able to get to the HVAC system. Makes sense. Then they're able to move to the point-of-sale network. Not so good. Segmentation is something we learned in the 90s in theory, but not yet today, apparently. We still struggle with segmentation across most IT networks today. I think almost all have segmentation issues in different points. So, once they were in the point-of-sale network, they uploaded some stage 1 malware. Seems fine, right? Take a look around, see what they are playing with. So, that they were able to, learn the lay of the land, upload stage 2, start to collect credit cards. Okay, in-memory malware, kind of tough, but in this case, their protection systems, ironically, FireEye, ended up detecting the stage 2 malware. So, from that point, there was about a 3-day period between initial detection and when credit cards started being exfilled. So, a 3-day period on detection, and they still hadn't remediated it who knows how long later. So, all the credit cards were able to be exfilled, so kind of a bad response to detection. But beyond that, what is the easiest way to find a ton of data leaving your network? Anybody know for a prize? If you have just a massive amount of data, yes, sir. NetFlow. Yeah, that's right. When you see, come get your prize. So when you have hundreds of thousands or millions of credit cards leaving your network, you can probably see that. It's probably going over a channel that you don't necessarily transmit a gig of data or whatever that is in text worth of credit card data, right? Regardless of the fact it was credit card data, if you have a gig of FTP and you don't normally use FTP outbound, it's kind of weird. So NetFlow would have been a fun way to detect that. Beyond any DLP solutions that, yeah, I'm not a big fan of those. I haven't seen much success with it. But before we go damning our particular retailer, we really have to be careful. Because, you know, the old saying, people in glass houses shouldn't throw stones, right? Is your organization really that much different? I mean, it's kind of bad, but like, do you have a full asset list of every device? Do you know what MAC addresses should be there? Do you have good segmentation in your network? Everywhere. From, say, separation between different departments. So, I don't know, HR and finance should be on, wouldn't say restricted networks, but more protected than, say, you know, random receiving and shipping, or whatever, depending on what your company does. There are certain areas that you want to protect a little more, segment off. Having very flat networks with very little segmentation is too common today. Having two-factor authentication on every single remote connection from outside in. To me, this seems like a completely reasonable thing and not expensive to do anymore. It really isn't. There's more and more vendors in the space. It's not just RSA anymore. They always had some options, but now things like Duo and other companies have done a good job of making it very easy. OAuth is free if you really have the time to implement all of it. So there's reasonable solutions out there to work on these problems. Response time to all tickets under 3 days is probably the most difficult one for most SOCs out there. A lot fall behind quickly and never really catch up. Part of that goes back to security engineering, but we'll come back to that in a minute. Application whitelisting, especially on high-value devices. So point-of-sale systems, as well as industrial control systems, come with one major awesome point for protection. We know exactly what's going to be on there, and most of them are very similar. So creating an application whitelist for point-of-sale is trivial, and you can test it. Industrial control systems a little harder. But most organizations today have servers and other things that they can build application whitelist profiles for. Additionally, endpoints, you can do application whitelisting pretty well. Deploy it in test mode and see what's triggering stuff, and then enforce mode. So these are features out there that a lot of organizations could easily implement, but they take time, engineering, resources. These things are hard sometimes. So if you were under the same situation where you had someone coming after you, how much different would your organization be? Again, while Target was a great example of a breach where they released all the information almost, there's not many where we have these lovely case studies where they release almost every detail of a breach for us to learn from. So that's kind of a hard problem, but specifically IDS is kind of my bread, butter, and potatoes of the SOC operations. So talking about that now a little bit, more detail. So kind of the four most common IDSs that I find today in organizations. Snort and Suricata, the two almost brothers. Bro IDS, which is kind of a different type of tool. And then FireEye. Obviously they're here today and having fun. So, break it down a little bit. Snort, from what I've seen, is the most popular. Again, kind of a jaded view given most of the time when I'm being brought in. It's for snort and Sourcefire type gear, it being open source, and then the corporate support through Sourcefire. Kind of nice if you want to do big deployments. Signature-based, started out in 1998. Kind of an interesting story with that one. Sniffer and More was how the name came about. I took some research to find. Suricata, kind of the offshoot of Snort. In 2010, they forked the Snort project to go a slightly different direction for Suricata. Still signature-based, but kind of a slightly different goal for Suricata versus Snort. And probably the most known difference is it's multi-threaded. Although, if you're doing a deployment big enough where a single thread is not sufficient with reasonable hardware, you probably should, look at an enterprise tool at that point instead of an open source. But I've myself done 10 gig deployments of open source Snort. It's doable. It's difficult, but doable. Bro IDS is actually the oldest of the group. Started out at one of the national labs 20 years ago, over 20 years ago. And kind of some interesting automated details. You can actually pull NetFlow out of Bro as well, which I thought was kind of interesting first playing with it. A lot of power, but probably, to me, the biggest component of it is it gives you a lot more visibility into what's going on in your network. Today, where we have ever-changing networks that no one has documentation for, asset lists are hard, being able to have a dynamic tool to do visibility and to see what's in my network, what's there, and notice changes, not just NetFlow, but in data types, can be really, really helpful. And about 10 years ago was actually when Bro really started to get going. Ironically, through funding, from what I've seen, primarily for industrial control systems, Department of Energy actually pushed for Bro really hard and kind of funded a lot of its ability to move to from a bunch of guys doing development when they had free time in the national lab to a full-on funded project that could sustain and really make a huge difference. Over the last few years, it's gotten way more popular with the ever-expanding networks to get that visibility. And FireEye, kind of a customized Snort and Cuckoo combined with some other, as they call it, magic and hunting. Unfortunately, this is the only closed source product of the group. Also started about 10 years ago, but my only concern is you can't really get detail of why something was detected and work on false positives. You kind of have to rely on them to do that. And I like fine-tuning. So, to me, you kind of come to a crossroads. What should I use? This is a common question that a lot of orgs end up looking at and just picking one without really looking at differences. So, to me, kind of the Bro is a little bit off on its own, gives you the visibility but not really detection of threats. So it gives you number 1 in that lovely phase cycle, not necessarily 2 and 3. Maybe 3. Maybe it'll block, it doesn't even have the ability to do blocking, because 3, prevention of known threats, again, Bro's not something you can really drop traffic on. So you come down primarily, in my head, to Snort versus Suricata. And also, rule-set-wise, emerging threats versus Sourcefire. And these two kind of go at the problem in 2 different ways. So Sourcefire and Snort are designed to look for specific threats. They're engineered to be better at looking for explicit threats, not necessarily IP addresses or threat indicators. Whereas Suricata and emerging threats are designed more around, I hear this IP is bad, maybe we should look at it. It's actually engineered to be more efficient on IP-based rules and other non-guaranteed indicators. So that's kind of an interesting detail from literally talking with developers last year at Security Onion Con, right after Security Onion Con, based on the emerging threats guy, who's finally getting one of them in the room and having the conversation of, why do you do IP-based rules? For Snort, they're awful in design. They don't work very well. And it's, we're primarily Suricata. Is Suricata designed for that? I don't know. It was the sales guy, kind of. So, ended up contacting some of the developers for Suricata. Turns out they do prioritize IP-based rules way more than, say, others. So, one of the first things in the analysis stack was IP-based rules. Seems reasonable. It's a different methodology. Sourcefire and Cisco, well, Sourcefire says, if you have an IP-based rule and you think it's bad, that's called a firewall rule. You block it. But, I don't know. To me, once you've gotten your known threats, that's when you can start to take care of, maybe this is bad. So, there's place for both, but one is better, one component, one is better than another. So, security engineering is kind of hard. It's a little complex, kind of like this, right? So, which logs are helpful? Kind of an easy question once you've been in a SOC world a while, but when you start looking at how to configure snort, it can be pretty daunting. There's roughly 2,000 lines of configuration for snort, in addition to the 30,000 or so available rules. So, that's a lot of information, a lot of choices. And the documentation, once you know all about it, it can be a decent enough reminder, but it doesn't really teach you how to use the product, how to configure it in either Snort or Suricata, both run in this problem. As a matter of fact, even while working at Sourcefire and after, the best documentation I've seen for how Snort is designed comes off the personal blog of somebody who never worked in engineering. He worked in product support. He ran, I know this is unreadable at this distance, blindseeker.com/wiki has this lovely chart. It literally goes through the components of how Snort processes traffic piece by piece. This is the only document I have seen that goes anywhere near this much detail on how detection works, at what stages certain things get thrown out, when certain components analyze traffic, and depending on how or what component has an issue with traffic, where it detects, where it drops, where it falls over. And then, again, this is off a personal blog. There was no document remotely close to this while I worked at Sourcefire, and my friends who are still there tell me they still haven't seen anything like it. So, kind of a hard problem when you really don't have documentation for design on how things work. So, deployment, kind of another fun detail. Obviously, Security Onion, fan favorite here, is one of the deployment options out there. Comes as an ISO. Really, if you're going for production, the ISO is not so great. You have 6 different GUIs. Do you really want a VM with 6 GUIs with all your company's protected data and security? Are you really going to go through changing all the passwords for all the GUIs, all the databases, everything? There is a way to deploy Security Onion via a package. So you choose the packages you want. Please, for the love of God, do not deploy the ISO in production for protection of your organization. I know there's guides online of how to do it with the package system. It's way better. Rock NSM is another tool similar to Security Onion. A couple of differences in that they chose one GUI, one database, or one database tool. They have all the things together, and they added Google Steganographer, which is kind of a cool open source free full pack capture tool. And then AutoSnort, same guy who did the design, made a tool where you set up your system and then you run his script and it will download and install all the tools. Snort, you choose a GUI, you choose things, so much easier. I don't know, different deployment options. So, steps forward. When you go back to your organization, get the SOC to start to really look at what's in their network and start to look at what are the things that are causing us the most tickets. If you have more tickets than you can manage, like most everybody, solving that problem of, okay, 10% of our tickets are this particular rule, it's a good place to start. Does anyone have any questions? Yes, sir. I would probably never deploy all the rules at once. There's too many that aren't applicable to the environment. Pulled pork is a lovely script that allows you to categorically decide what rules to use and what rules not to use. I normally would start with one of the predefined policies. So there's 3 available: security over connectivity, connectivity over security, and balanced. And then turn on and off categories and rule types based on that. And I turn off. There's a bunch of really annoying ones, things like echo requests, ping echo reply. These aren't useful rules unless you're just trying to drive yourself insane. So there's just a lot of those rules, and so turning it on, starting with what you think is about right and adjusting from there, turning on specific threats you are concerned about and certain ones you aren't, by OS, by application. It's a good place to start. It is a living process. It is something that takes a significant amount of time to work on. Other questions? Yes, ma'am. So that's not necessarily particular to an IDS, but more basic network analysis. That's something that's learned. There's not really a great mechanism to learn how to identify good versus bad yet. It's kind of one of the hard problems of the SOC world. And finding an answer is kind of like, how do you learn decision making, right? That's not a question that I can answer in a minute. I'm still working on how to figure out what the best way to teach basic network analysis as far as, is this bad or not? It's not an easy problem. So that's a different problem. That's not a stage of how far in and out in ability to see your SOC is. That's more around your people specifically. Do they have the skills, right? This is more maturity of an overall SOC rather than maturity of individuals. If someone in the SOC can't figure out how to detect if traffic is bad, that's more of a fundamental people problem. And I know a lot of the way that people start is literally jump in and hope you don't drown. Again, that's a large problem for the SOC community that we haven't had answered. A lot of it is keep going, analyzing that particular traffic until you know what it is. If you don't know what it is, figure it out first. The tenacity to do that is hard. I'm out of time here, I think. I will be around after.
As far as understanding what's known bad, that's baseline. And you wouldn't have a junior SOC analyst do that. You would have either the architect.
Yeah, so
Let me go give this